So as you could see,
Yes, sir. Thank you.
I've just made one small presentation just to have a help of the presentation while discussing the topic. Now, more often than not, I find one thing very peculiar that I find in agricultural graduate is they believe that agricultural sciences is not a prime important science, and that's why we don't want to prepare for JRF or SRF because it is having no glamour, or it is not having that much of a craze as civil services or some other careers. We need to understand how things work and what actually benefits the humanity and what is being credited to benefit the humanity. Those can be two different things. So if before starting, I should start with the quote of a Daniel Servets. I always start my presentations whenever I'm discussing with other students or colleagues. I always start my presentation with this particular quote that no field of science has ever been more criticized by the other scientific community as compared to agricultural sciences, and no field has ever consistently produced more benefits for human than agricultural sciences. So if we think the entire basis of a civilization or whatever we have is an outcome of agricultural success of agricultural science, and the other sciences come into picture later. So when agricultural sciences have already contributed to the cause. So more often than not, people make a mistake of uh, relating fame with the importance, which is not right. You can be important, you may not be famous as such. Okay, so that's why while choosing a career in agriculture, specifically agricultural research, don't relate or don't undermine or don't underestimate the importance of agriculture and agricultural sciences as such, right? uh, I assume there is no so much of uh, media coverage when it comes to agricultural sciences as we compare it to medical science or space research, but we are far more important than anyone, and I can take a lot of pride in saying that. Anyway, so coming to the next part and the main part of the discussion is how to prepare for SRF, JRF, SRF, NET, or ARS in agricultural stream. Uh, so now let's actually think of how this entire system works. So the system basically designed is in such a way that you need to have a knowledge first. So you need to read all those books that are very important. Then you need to have a temperament where you need to read it in a particular fashion. So if I'm going fast, please do intervene me in between. So you need to read the list of books that is given to you. There is no shortcut to it. Okay, first and foremost, you need to finalize the list of books and read that list of books. So there is no solution, though no alternative to the first mantra or the first component of success: read, read, read. Now even if you read, you may not get a good rank, or you may not get a good admission, or you may not get selected in ARS, because the second part of the success, or second component of the success, is a temperament. So while reading, you should read with the patience and strike a proper balance of reading one paragraph at a time. Most of the people, more often than not, get overwhelmed. They think like, okay, this is huge syllabus. Plant science is a big group. My subject has so many competitors, those things. So that's not how the things work. All you're supposed to do is read one paragraph at a time in such a way that you get highest amount of clarity out of that paragraph. As we all say, Rome was not built in a day. You don't build a particular building in a day. You build it over time. So even if the book list is more or the syllabus is huge, just focus on one thing at a time. One day, one paragraph, maybe one when you get efficient, or during your second or third reading, you can even read 3-4 chapters in a one day. And like last a few months of preparation, you can read even a book in a one day. So prepare with a patience. Units So that is the important thing. Now, skill, that is, there are people who have read a lot, they have read it well, that is temperament, they have read it well, they know things, but the problem arises with the way they attempt exams, with the way they, it's like if I relate this story with a sport like cricket. Some of them have an ability to play, that is called knowledge. Some of them have aptitude to play, that is they have a knowledge as well as proficiency, they can play it in a better way. But only a few of them have success in their sporting career because of the essential component, that is third component, training. You may be the batch topper of your batch, okay, you may be very smart and you can read it in one night, one notes in one night, but that is not how the big exam works. You can read it like for a semester and you can read overnight and get 8.5. Okay, that is different. But when you're reading for JRF or SRF or NET or ARS or any other exam that involves huge competition, there you need to have a particular level of skill to execute that knowledge into reality. That is, solving the questions based on your knowledge also takes certain amount of training and guidance. So how many questions to attempt, how to attempt, that part is also essential. So I have included that also, how many questions to attempt and all that. So let's, sir, I hope it's okay with you that I'll take another half an hour while discussing how to attempt exams, and the teaching part or the topic will be discussed in later 30 minutes. I hope that is okay. I think some of you have already we might have had an interaction on this aspect of exam strategy, because I think we conducted several trainings. Even the CAST program of MPKV conducted one JRF training, and there also I spoke. So coming to the exam strategy for JRF or SRF or ARS, I have included all three, so I'm going to spend 2 minutes each. So in JRF, they have 120 questions. This is based on last year. So if they have changed it, let me know. If the new notification is there and they have changed it, I don't know. It is based on 2020. I don't know what has happened in 2021. Anywho, for JRF, if you're preparing for any group, so you remember there are 120 questions and they are all basic questions. Okay. And then they have given you 120 minutes, and uh, the slides are working now, or it is stuck. Hello. Hello. I think now it is visible. Is it? I don't know why the slideshow is not working. Hello. Hello. Is it visible now?
Yes, sir.
Okay. Thank you. So when it comes to JRF, solving JRF questions, one thing we need to remember that they have 120 questions, 120 minutes, 1/4 negative, and it is completely based on the basic knowledge of a subject, right? So there is no much of a fuss. They don't ask too detailed questions. They ask very basic things. And always remember one thing. I'll just put it in the box. There will be 5 or 10 questions that are tough, and they really involve a severe amount of preparation. Okay, so what we need to remember, those 5-10 questions should not change the way you prepare. That happens in every exam. If you start chasing the question, you will never be able to achieve any success. So in our time, when I prepared JRF in 2013, we used to say, if you know everything, probably you're not going to get JRF. because that is not how this exam work. All you're supposed to do is to have a good amount of knowledge and apply that knowledge in that particular exam. You need not to know everything. So the rule of 1990 or 9085 is that you should attempt 90% of the question with 90% accuracy or 85% of accuracy, right? Or you can reverse it in this particular, that you can attempt 85% question with a 90% accuracy. Other way around, in a way to say you should have at least 85 plus correct answers after subtracting your wrong answers. So you should not attempt out of this 120, even if the paper is very easy, you should not attempt more than 110. There will be 10 questions. Even if you read everything, there will be 10 questions that you may not know. So don't change your preparation, because during this mock test and all, people will solve mock tests. They will get 2-3 questions that are unrelated, and they will panic and say, okay, I have prepared everything, but still I'm not getting a command of it. Don't worry, you're not supposed to get command of it. All you're supposed to do is to score a rank. So if you want to get JRF, you should attempt not more than 110 questions, even if the paper is easy. If it is easy, 112 maybe, not more than that. And the second aspect is your accuracy should be very high. So if you want to get JRF, accuracy 90%. If you want to get just a good rank, even 75% plus 75% plus accuracy is good enough. So let's assume I just want a rank, not JRF. No, it's not that you don't want. You may not get, if you're not prepared well, you may get just a good rank, not a JRF. So in that case, say I have attempted 100 questions, my accuracy is 75-80%. So even if I get 75 correct or 80 correct, I'm still in a good rank. Okay, so the basic funda is, if you want to go for JRF, 85 plus correct. If you want to go for good rank, it can be just 75 plus. So I'm just saying a random numbers. I'm not saying because if the exam is easy, this accuracy factor could go 5-10 questions up. So instead of 85, you mean 90 for getting JRF if the paper is easy. And if the paper is difficult, it can come as low as from 85 to 75. That can happen. But in a normal year, if you want to go for a JRF, you should be having at least 85 plus correct answers. When I say 85 correct, because out of those 120 questions carry 480 marks. And when I say 85 plus correct, that is somewhere around, that is how many? 170, 340 marks. 340 out of 480 is up to 70%, 70 to 75% marks. Because I have seen some cutoffs of previous year, it is somewhere around that only. And a risk, as we all know, there is 1/4 negative, so don't attempt too many. Most people that I have seen in MPKV, I don't want to sound different. I'm just saying it because I have discussed with so many people. They have a habit of attempting all questions. That's not a good thing, because then you're entering into a phase where more negative is causing the main damage. Okay, so that is not a good thing. If you don't know, don't attempt. If you know 50%, do attempt. If you know 25% and total attempts are less than 90 out of 120, then you have to take a chance. But if you don't know anything, don't attempt. I think one is correct. That is not how the exams work. If you know, even if you can remove one option, then you can attempt that question. But if you can't remove anyone, all the 4 options are equal to you, that's not a healthy way of attempting. So for SRF, they have changed the pattern. For SRF, 120 questions, and they have this school of crop improvement and all that. So what they have done is, the first 20 is for general, the 50 is for main subject. So let's say if you're a genetics student, then 50 questions from genetics, and then 50 questions from PGR, plant genetic resources, and seed technology. So they call it as a main subject and then core subject. Okay, so there are three or four subject. Your subject may have 3 or 4. So crop improvement, school of crop improvement has your genetics, seed technology, and plant genetic resources. If you discuss a school of social sciences, it will have extension, economics, and I don't know exactly. So there may be some other. So what we need to do is to understand that even if you attempt 14 out of these 20, then in your main subject, that is your own subject, if you're in entomology, you should attempt 46 questions from entomology. Then for pathology and nematology, you can go a little less and attempt 35. So the subject you know, you should attempt more than 90%, right? Out of 50, 46 means 92%. The subject you know little lesser, you should attempt at least 70%. So 35, 50, 70%. And the current you can at least attempt 12 or maybe 14, right? So the idea is do not attempt less than 95, do not attempt more than 110. Okay, this is what I was talking about when I said the exam is knowledge, temperament, and skill. Sometimes you want to just go with the flow and attempt every questions. That actually means you don't have a particular uh, temperament for the exam, because I have also attempted these exams, and whenever I have attempted more, I have lost it, and whenever I have attempted less, then also I have lost it. So it's always better to find out a number. And when I say not at more less than 95, if the paper is too tough, at least attempt 95. If paper is very easy, even then don't attempt more than 110. Maybe you can attempt two, or as I said, one or two questions extra, but not more than that. So normally the questions you should attempt is more than 95 and less than 110. This is for SRF, okay? Because in SRF there are very few seats, and then again for SRF fellowship, again very few seats. So first 20 questions, you don't need not to prepare a lot on those. That is called don't chase the questions. Just prepare for these 50 plus 50 and one simple notes of these 20 questions. Okay, so even if you could attempt 110, that's uh, brilliant. Now let's come to ARS. Okay, now unlike these JRF and SRF, ARS is 100% subject. So uh, there is no problem of how much not to attempt from one section and how much to attempt from another section. It's a very simple thing. Now, so for ARS prelim, if you're talking about that, so for ARS prelim, you can just for ARS prelim, you can attempt out of 150, since there is a one-third negative marking, you should attempt more than 110 and less than 135. If you want to write mains and give interview and all that, you should attempt more than 110, but you should not attempt more than 135. I have seen people attempting way more than that. So as I said, if it is way easy, I'm saying it for a normal years. If it is very easy, you can attempt 3-4 extra, but not more than that. Then that is the way it goes. So for ARS, this for NET and this one, it is in this slide. For NET, you have like 50% for general, 45% for OBC, and 40% for SC/ST, I guess. Correct me if I'm wrong there. So attempt, as I said, for NET, you can attempt 10, 15 questions less. You can attempt anywhere between 100 to 110. So it's very easy when you decide that I'm only going to attempt 110. This year, I just want to qualify NET. So if you want to just qualify NET, attempt 110. Leave 40 questions out of those 150 questions. If you can leave those 40 questions and only attempt 110, your accuracy will increase. Okay, and automatically, even, or you can say 120. If you attempt, if you feel no, I'm not that accurate, attempt. You can leave at least 30 questions without attempting. That 30 means if you attempt everything, you are going to with 1/3 negative rule. Those extra 30 will cost you 10 accurate answers. So for NET, you should attempt like this. Now for mains, this is the cutoff. So you can see here, it is possible that you may qualify for mains, but you may not qualify for NET, which has happened in physiology department this year. So if the paper is tough, even mains cutoff goes down than the NET cutoff. So attempt 120, 130 if you are writing, if you want to write for mains, because if the number of seats are limited, if the paper is normal, unlike a physiology question this year, apart for those extreme situations, apart from those situations, generally this is the desirable amount of attempts that one can go for. Anyhow, so I have okay, I covered only prelim part. So for mains, if you have any questions, just put it in the chat box. We can discuss those questions later. So for mains, what they have is they have 40 objectives and then 20. It's like 40 plus 20 plus 6. This is the pattern that they follow. I don't know if they have changed it this year or last year, but I think this is the general pattern they have. So 40 objectives for 2 marks each, that is 80 marks. Then 20 questions for 5 marks, so 20 into 500 marks, and 6 questions for 10 marks. Right? So those 40, 26, that equals 240 marks. So the first funda is you have to write each and every question because there is no negative. Do not leave blank. Okay, you have to have a practice of writing because we are going to write somewhere around 40 to 45 pages, and that's not an easy thing. You're going to write and process everything in that 180 minutes. So the writing practice becomes very important. The first 40 questions you should attempt, those MCQ you should attempt in 30 minutes. The next 20 questions of 5 marks, you must like get go somewhere around this 90 is 90 minutes. Okay, and this last 6 questions for 10 marks, you should use 40 minutes on that. So 90, 30, 20, 120 plus 40 is 160 plus 20 minutes for other activity like underlining, gap filling, and I should not use the word thinning because you are not supposed to scratch the answers. But if you feel that you have committed an error, then you can like take 1 or 2 lines out of it. But don't inculcate that habit in your answer writing. So main score generally varies. It varies as per the category. It varies as per the number of seats. So the ratio of for interview changes automatically. If there is only 1 seat, I can't guarantee even 160 plus marks can give you interview. But sometimes it happens that even 140 guy can be called for an interview. If the seats are very high, then the proportionate numbers for interview is also very high. So no one can guarantee that. So it all depends upon the number of seats that you're looking at. And then interview general. This is my interview. And when I say thesis, subject, and personal, this is my interview. So they asked most of the questions were from thesis, then from subject, and then from my uh, personal aspect of my life. So that is the core of what I wanted to discuss in the first place. And since the topic given to me is this series germination viability vigor, which we will discuss, but as I said, this topic is far relevant to only those guys who are plant science JRF or SRF or ARS aspirant. For other people, it is relevant, but not like too much scoring area. But so before discussing this topic itself, I would like to have 2 or 3 questions on what we have discussed till now, so that the later part will be far more smoother and we can run faster through it. So I request you to kindly raise some questions up to this because uh, I don't want to end the germination viability vigor topic and then ask you to ask me about how to write prelims. So that makes it a bit complicated, right? So if you have any questions, please put them in the chat box with respect to these area that we have that we have discussed till now. Okay, so anyone there? You can simply put questions in chat box. Right? And for this book list, uh, you people may be knowing that some IRI students have started YouTube channel. So what they do is they take people like me and those who are better than me, obviously. So they conduct interview of those people and they post it online on YouTube. And they have, in each subject, almost each subject they have covered. So list of books, how to read, that number of tests that one should attempt, and all those. So I'll put that name also. I find it right now. I'm not recalling him. Uh, so if you have any question, please go ahead and just put it in the chat box, or you can simply ask. So I guess okay. You can put those questions in that chat box. I'll answer it later also. Okay. So we need not to stop for that. Anyways, so book list, I was telling about the book list. Here the references are given by Dr. Bipin Kumar. That channel is run by Dr. Bipin Kumar on YouTube. Okay. So he conducts interview of toppers each year and he posts them online. You can find the list of books these toppers generally refer. So I may be a bit outdated as of now, because I gave JRF in 13 and SRF in 15. So you can refer those, Dr. Bipin Kumar YouTube book list. Okay. So since I don't find any question in the chat box, and we still have one topic to cover. So seed germination, viability, and vigor. This is the first topic that we are supposed to discuss. And we all know what is seed. Okay, so seed is fertilized, mature ovule containing an embryo and storage tissue. Now I have put a question mark after fertilized because we can have a non-fertilized seed. And I think you all know what that non-fertilized seed could be. It could be apomictic seed, that seed develops without fertilization, or it could be somatic or synthetic seed. So you just take a somatic tissue and go for a tissue culture, and that way you can have a seed that is not an outcome of fertilization. So whether to call that as a seed or not is a debatable issue. But for JRF or SRF, for these exams, when we say seed, it is they are referring a fertilized seed. So true seed they are referring. All those apomictic and tissue culture synthetic seed, they are part of asexual reproduction. So that is not a seed. Now, so the difference between seed quality and quality seed is, the quality seed is a material or the object, whereas seed quality are the parameters. So someone is brilliant, that's brilliant is a quality, and someone is that particular individual. So here, when I say that seed has a quality, I'm talking about a material. And when I say that seed has a quality, and that word quality is nothing but the parameters. So parameters such as germination, vigor, viability are the parts of a seed quality. And any seed that has good amount of these parameters is called quality seed. Anyway, so what? So there are basically two types of seeds. Okay, and this classification comes into picture because the development of seed happens in a different way after fertilization. Here you can see, after fertilization, the embryo divides and redivides continuously. Okay, so when it divides, it goes through different phases. That is called globular phase, cotyledonary phase, or embryonic phase. So here you need to remember one thing. This is called embryogenesis, that is morphogenesis or embryogenesis. Then there comes a phase of rapid endosperm development. Sometimes the endosperm gets absorbed in case of dicots, and in case of monocot, the endosperm stays there. That is the phase of maturation. And the third phase is the phase of desiccation drying. So here let's take a case of soybean. So in soybean, after fertilization, the embryo will go through globular, cotyledonary phases, and then it will, the endosperm will be absorbed into the cotyledon, two cotyledons, and that cotyledons, after a particular stage of maturation, it will start drying. So the greening, the chlorophyll gets degraded, and the leucoplastid part becomes dominant, and seed turns yellow, or the degreen happens. But principally, it is degreening that is important. So sometimes the degreening, that is chlorophyll degradation, is coupled with synthesis of phenols and tannins, and the black seed develops. But if the synthesis of tannins or melanin is less, then the colorless seed coat will develop. Okay, and if the embryo, that is cotyledon, is having yellow color, then the seed coat will appear yellow in nature, and the entire seed becomes yellow. So that is the point. So seed basically is a fertilized uh, mature ovule. When I say mature, they are talking about this phase. And this desiccation or desiccation derived dormancy phase does not come into picture of all the seeds. And that's why this particular thing, where Robert and Ellis classified the seeds into two categories, orthodox and recalcitrant. Orthodox is the one where moisture can be brought down to 5% without causing any effect on its viability. So like rice or wheat, they can be dried. Orthodox means they can be dried. Recalcitrant, they cannot be dried after a particular percent moisture. So generally, they cannot be dried below 20%. So these are the two basic categories of a seed. So for recalcitrant, most of the horticultural crops, they have a recalcitrant seed. I said most, so there are some exceptions, but most of them are recalcitrant. So the problem with the recalcitrant seeds is, since they cannot be dried, they cannot be stored for too long, and they cannot be stored in gene banks without having a specific set of treatments. So this is the seed development part. So morphogenesis, maturation, and desiccation. Then here you can see the seed has this as a life. So once the seed is developed and it is dried, that's when we keep it for a germination, the seed will take moisture. Rapid uptake of water is called imbibition. It's a physical process. Then upon reaching the critical hydration level, CaHL, the seed will start its activities such as, this is the list of activities that we are talking: respiration, DNA repair, DNA synthesis. And after completing all these essential activities, the seed will enter into the phase of germination. That is the emergence of radicle, phase 3 that we are talking. Hello. So here you need to remember one thing. Once the radicle emerged up to 2 mm, 2 millimeter, the seed is said germinated in physiological sense. But for seed technology, that is not a germination. Okay. So the question can come like, what is seed germination in terms of seed technology? So in seed technology, the germination, seed germination, is a phase where complete normal plant development occurs. So the seedling has shoot, root, leaves, and plumule, and all that. If those aspects are there, only then it is categorized as germinated seed. Whereas for physiology, even if there is an emergence of 2 mm radical, and if the seedling does not develop well, or if it dies, it is called physiological seed germination. So that particular gap of definition is there. So let's understand this particular slide again. So there is imbibition, and then activation of components, and then there is growth. But if you don't allow the seeds to grow and if you dry them back, then that drying of imbibed seeds before they emerge their radical is called seed priming. Here it is, seed priming. And those primed seeds are, hello, so those primed seeds are dried back. And during this, the priming actually causes increase in the germinating abilities and increase in vigor. So seed priming is very well known uh, word or very well known practice in seed technology. Priming refers to controlled hydration, where once it reaches this phase 2 of a germination, that is activation, it is dried back. And seed priming increases the ability of the seed to germinate across the spectrum. Okay, so what do we need to remember from this seed germination? This particular thing is the seed germination. Seed technologically, it is not just 2 mm emergence of a radical. The complete seedling has to develop. Physiologically, it can be just a 2 mm protrusion of a radical is called as seed germination. It goes through 3 phases, that is imbibition, reserve utilization, and radical emergence. So the basic difference between germination and priming is that in priming, you have to dry the seeds before the radical emerges. So that is the difference between germination and priming. The essential requirements for germination are water, oxygen, temperature, light, and darkness, light or darkness. So these are the 4. You can find substrate somewhere, but as we all know, seeds, since they have their own storage tissue for not for a longer period of time, but for a specific initial period of time, they can germinate without substrate. Okay? Even hydroponics or the soil, we can see seeds germinate on uh, non-nutritive subjects such as papers that we use in a laboratory. So the paper is only providing balance or space to hold itself. Otherwise, it is not providing any nutrition. So as far as germination is concerned, substrate is not a very important requirement. But you do need water, you do need oxygen, then sufficient temperature is required, and then light or darkness. So why it is said light or darkness? Generally, we talk whenever we say requirement of germination, we say light. We never say darkness. So there are some seeds that germinate well in the dark conditions, right? And that happens because of this PR PFR conversion. So since I cannot start, the slideshow is not compatible with this Zoom. I think there is some issue. I'll just uh, you know I'll just here explain it in this slide by stretching it. So what happens? Some of the seed, this PR, that is phytochrome red, is inactive form of phytochrome, and PFR, that is phytochrome far red, is active form. So when there is so the seeds, if the seed needs to germinate, it has to have this PFR, right? So some seeds, their default status is PR. They have inactive phytochrome red. So once they get red light, they will germinate because the PR will be converted to PFR. They will germinate. But some seeds, they even a dried seed itself has a PFR. Any further light means only far red component will be absorbed, and the active will be converted into inactive, and the seed will fail to germinate. That is we call negative photoblastic. That is seed failing to germinate in light. Negatively photoblastic. This negative photoblastic case happens because the active PFR, which is required for germination, absorbs far red light from the color of light from the light source that we give, and it converts into PR, which is inactive. That's why there are some seeds that don't germinate in light. Okay, so uh, those seeds are called darkness required seeds. Unless you give them darkness, they won't require. Snake guard and pointed guard are those two examples that I can remember as of now. So this is seed germination test, and this is seed germination specification. Who gives the specification? ISTA or ICAR or SAE or even private companies. They find a particular crop germinating best at X temperature and on a particular type of medium in particular fashion. Top of the paper is generally used for small seeds. Between paper is for larger seeds or larger seedlings produced from those seeds. And top of the paper is also useful for those seeds that require light, whereas between paper can be used for the seeds that require darkness or they do not require light as such. So first count is referred as when you count, because some seeds may germinate faster. So on the first count, you count those fast germinating seeds and remove them from the plate. And that also helps in lessening the crowd or decreasing the crowd. And final count. So if whenever you are putting seed germination experiment in your lab, you're supposed to have these things in your mind. Selecting suitable substrate, placing of the seed is important, whether it is top of the paper or between paper. The temperature is also important. For Rabi, it is generally 20 degrees Celsius. For Kharif, it is 25 or even 30. Okay. And then first count and final count, those are technical things, but you just need to remember if the vigorous seeds are there, you have to remove some seedlings, and then there is a final count. Okay. And the treatments are like dormancy breaking. And I just have taken one example how the basic requirements of a seed germination looks like in laboratory. So these are the table that we follow. It is in the book of ISTA, International Seed Testing Association. Then in evaluation of germination test, we have normal, abnormal seedling. In normal seedling, as I said, in seed technology, only normal seedling is a part of seed germination. Not all the embryo here. This first image is a normal seedling. Okay. In second, you could see this is abnormal. This is abnormal. This is abnormal. Okay. So abnormal are 3D, that is diseased, decayed, and deformed. So any seed that is diseased or decayed or deformed, it is called abnormal. Fresh ungerminated seed that take water but don't germinate, they have embryo dormancy. There will be some seed that don't take water at all, that is called hard seed, physical dormancy. There will be some seed that take water and they are oozy, lost their glow and all. Those are called dead seeds. Seed viability. Viability is nothing but a state of aliveness, whether seed is alive or dead. That is called viability. So what is the difference between viability, germination, and vigor? Viability is whether it is alive or dead. Vigor is what percent of it is alive. So I'll cover that vigor aspect. So vigor is like if I ask 3 people to run 1 kilometer, it is possible that everybody will run 1 kilometer. But the more important is who came first, who came second, and who came third. The one who came first has a high vigor. Second, medium vigor, and third is a low vigor. But since all of them reached, irrespective of time, it is viability. Okay, everybody was alive because they could run. But since the one who ran it faster is the most vigorous one. The difference between viability and vigor is the seed that can germinate is called, the seed that is alive is called viable. The seed that can germinate faster is called vigorous. So viability test could be the viability test. The most famous is tetrazolium TTC, or triphenyl tetrazolium chloride, which uses hydrogen, and the dehydrogenase enzyme converts this TTC salt into formazan, red color formazan. The other test like germination, excised embryo test is used for. So these are the objectives actually. Germination is the most authentic test for viability. TTC is the most rapid test for viability. Excised embryo is only used for woodies and certain forms of deep dormancy. So the seeds that take 70 days, 90 days for germination can be checked through excised embryo. And X-ray analysis is generally used for this chaffy seeds, so light-weighted grasses or forageous seeds. It is checked through X-ray. Okay, so this is like 4 objectives: most authentic test used for tree species, most rapid, and used for forage crops and chaffy seeds. Anyway, So this is rapid seed viability test, that is triphenyl tetrazolium chloride. So all those live cells will emit hydrogen, which then reacts with TTC and forms red color called farmason. All that area which has a red color is live area, and the white color is a dead area. For monocots, this is called lateral embryo positioning. So even if the lateral part is colored, it is live seed, because this is endosperm. So endosperm need not to be uh, alive as such. So seed vigor, as I said, since I can't play it on a slideshow here, I should tell you that seed vigor is nothing but something in addition to germination or viability. So if it is faster, if it is rapid, if it is uh, luxuriant, that is vigor. It is dull, it is uh, what we call slower, that is just a state of aliveness. Okay, so seed vigor is an outcome of genetic makeup, maturity, is growing conditions, provenance, that is area, and the health and all those aspects of seeds. So these are the tests for seed vigor determination. So seed vigor tests, like physical tests like size, bold seeds are generally more vigorous. Physical soundness, broken seeds will be less vigorous. In X-ray, completely filled seeds are more vigorous. Performance based, like first count, speed of germination, seedling growth, seedling drive it, electrical conductivity. Stress, so cold test is used for uh, cold test is used in case of maize. Brick gravel test given by Hiltner, paper piercing is generally used in most of the crops. Accelerated aging test, soybean. Controlled deterioration, rapeseed and mustard. A radical emergence test, now it is used for maize and brassica. So these are the vigor tests where you give them a stress and find out which one is performing better. So cold is a test, cool test is conducted for cotton. These are the objective generally they ask. So first count is like, as we discussed, first count is first luxurious seed will grow faster, so you have to remove them from seed plate. That is called first count. Speed of germination, any seed that germinates faster and will be more vigorous. Seedling growth, vigor index 1 and 2. Some of you might have heard seedling vigor index 1 and 2 of Abdul Baki and Anderson. So these are the different tests that we generally conduct for vigor, and we have already seen viability and germination. In nutshell, I am not discussing a lot because this is a heterogeneous crowd. So unless and until we are focusing on only males driven questions, then I don't see many of you would be writing ARS in SIG technology. So those who are writing can have a different discussion with me, and those who are other than SIG technologists, I think this much is way more sufficient for all of you. So this is a very small, very brief and very general intro of this particular topic, and as well as this how to attempt these exams. Sir, I hope these participants will interact with their questions and queries in their mind.
Hello.
So,
Hello. I'm audible.
question.
I am audible.
The seed.
Hello. Hello. I'm audible.
Yes, sir, you are audible.
Okay. So,
Yes.
is there any queries? from the participant. So please ask to Dr. Swami. I hope you understood properly that basic thing, how to prepare
Yes, that was the
for
prime
the NET
focus.
ARS examination. Interested in that, so you can follow his instruction. So this is a good initiation. So I think if there is no issue, so we can conclude this session today. So tomorrow we will continue this lecture again as a second part. Okay.
Okay, sir.
So thank you very much, Dr. Swami sir. You accepted our invitation and delivering such a nice lecture. And it will be helpful for a bright future per student. So they are interested highly. They are interested in the 8 nearest examination. So most of the people are continuously trying how to prepare, how to collect the books. So I think next day means tomorrow, if we are conducting this lecture, so you can give the information pertaining that. So which books is useful or they may refer. So that type of idea you can give also there. So thank you very much for such a
Yes.
nice and
Yes.
wonderful lecture. Thank you
Thank
for your sparing your valuable time with us. Thank you very much.
Thank
So
you, sir.
with these words, I conclude this meeting today.
Thank you.
So again, I kindly request to participant. Tomorrow we will start the meeting at 10:30 a.m. So I will share the link to you in the group. So accordingly, you can join the meeting before 10 minutes. So thank you very much, sir. Okay.
Thank you.